Hi, I'm Alex from EDD Academy, and I'm going to be walking through the Math No Calculator section of CollegeBoard's official SAT practice test number 2. I'd like to note that this is going to be a considerably longer walkthrough than my previous video because I really want to get through all the steps for each problem. So let's get into it. Question 1, we have the equality that 5x plus 6 equals 10, and we want to find the value of 10x plus 3. So we can solve for x. So by subtracting 6 from both sides, we have that 5x equals 4. That means x equals 4/5. Plugging back into what we are trying to find, 10 times 4/5, which is x, plus 3. So here we have 10 times 4, which is 40, divided by 5, that's 8. 8 plus 3 equals 11. That is answer choice C. Moving on to question 2, seems to be a simple systems of equations that we can solve with pretty much any method, so let's go ahead and do that. X plus y equals 0, 3x minus 2y equals 10. Immediately, I notice that we can cancel the x here if we multiply this top quantity by 3, so let's do that. So we have that. 3x plus 3y equals 0, and 3x minus 2y equals negative 10. Canceling the x's there, solving for y, we have that 5y equals negative 10. Dividing both sides by 5, y equals negative 2. We can plug this back into the top equation, so we have that x minus 2 equals 0. That means x equals 2. This is our solution. Question 3. We're given an expression that estimates the price of a job, and we are asked to find the best interpretation of the number 12 in the expression. So we see that we can kind of identify our parts of our linear expression here. 60 is the y-intercept, and 12 seems to be a sort of rate. So we can look for the answer choices for a rate. And question A fits that. Moving on to question 4, we are given an expression and we are trying to find an equivalent expression in the answer choices. Okay, so we have that 9a to the 4th plus 12a squared b squared plus 4b to the 4th. Okay, so immediately we can cancel choices B and D because expanding those to the 4th power wouldn't make sense in this expression. So it has to be one of A and C, and algebraically we can notice that this simplifies to 3a squared quantity squared plus 2 times 3a squared times quantity 2b squared plus 2b squared quantity squared. Thus, we are looking for a term with a 3 as the first choice, and that is A. Number 5, we're given an equation again. We're given an x value, and we're trying to solve for k if k is greater than 0. Thus, we can just plug in x into our equation. So we have that. Minus 7, which is x, equals 0. And we want to isolate k as best as possible, so we can add 7 to both sides. So we have that. The square root of 2k squared plus 17 equals 7. So we want to get rid of the square root, so we can square both sides. So we have that 2k squared plus 17 equals 7 squared, which is 49. Subtracting 17 from both sides, let's bring it up here. 2k squared equals 32. If we divide by 2, we have that k squared equals 16, and that's k equals plus or minus 4. But we know that k is greater than 0, so our answer is 4. We're given two lines here, line 1 and line 2, line L and K, and we are trying to find the value of p. So they're parallel. That means they have the same slope, and we can see that the slope of line L, so we have that y2 minus y1 over x2 minus x1. So our rise over run formula equals, say y2 is 2, y1 is 0, 2 minus 0 over 0 minus negative 5. These convert to a positive. Our slope is 2/5. So we want a line with slope of 2/5. We want a line that is parallel. So we can set up a little bit of a proportion. We can say that 4 over p equals 2 over 5. Cross multiplying, we have that 2p equals 20. That means p equals 10. Answer choice D. Okay, a little bit of exponents here. We can rewrite x to the a squared over x to the b squared. Using our properties of exponents, this can also be written as a squared minus b squared equals x to the 16th. Because these have the same base, we can set their exponents equal to each other. So thus, we know that a squared minus b squared equals 16. This is a difference of squares. So we can factor this now into a plus b times a minus b equals 16. However, we have to look at what we're given. A plus b equals 2. So that means we have 2 times a plus b equals 16. Thus, a minus b has to be 8. So, question 8, we are given that the measure a in degrees of an exterior angle of a regular polygon is related to the number of sides n by this formula. And if the measure of an exterior angle of a regular polygon is greater than 50 degrees, what is the greatest number of sides it can have? Thus, we can just plug in 50 as a, our angle, into this. So we have 50n equals 360. However, we're trying to find the greatest number of sides it can have, so that asks for an inequality. So we have that 50n has to be less than 360. Solving for n, so we know that 50 times 7 is 350, so the maximum number of sides it can have is not a full 8, so it's 7. Question 9 gives us, looks like 2 lines with certain characteristics, and we're supposed to find their intersection points. So, we know that line 1 has slope 2 and contains the point 1, 8. Thus, line 1. Okay, so this can be written in the form 2x plus b, where b is our y-intercept, because it has a slope 2. And then we can plug in our point here. So we have our y value is 8, so 8 equals 2x, and x is 1 in this case, plus b. Subtracting 2, b equals 6. So that means our line has the equation 2x plus 6. Line 2, we're not given a slope immediately, just 2 points, but the slope is pretty easy to find using our rise over run formula. Doing so, we have 1 over 2 minus 1. Thus, our slope is negative 1. So we have a line of the form negative x plus b, where b, again, is the y-intercept. And plugging in either of these points, we have that 1 equals negative 2 plus b. Solving for b, b equals 3. Thus, the second line has the equation negative x plus 3. And we want to find the intersection points for these 2 lines. But instead of the coordinates, the points x, y, they're given in terms of a, b. So we can just replace the x coordinate with a and the y coordinate with b. So that means b equals 2a plus 6, and b equals negative a plus 3. If we want to solve them, we can basically equate each other. So 2a plus 6 equals negative a plus 3. Solving, we have that. Add a to both sides. 3a plus 6 equals 3. Subtracting 6 from both sides. 3a equals negative 3. That means a equals negative 1. Substituting back into this equation to solve for b. We know b is negative a plus 3. Negative times negative 1 plus 3 is 1 plus 3. So b equals 4. And we're asked for the value of a plus b. A plus b equals negative 1 plus 4, which is 3. We have answer choice B is correct. For question 10, because we don't have a graphing calculator, we kind of have to think intuitively about these graphs. So the absolute value of x has its lowest point at the origin, but because it's shifted vertically, it is not always greater than or equal to negative 1. The same for y equals x squared minus 2. The graph of this looks a little bit like this, where its lowest point is 0, negative 2. If we notice here, no matter what x value you plug in, negative or positive, its value is squared, which always gives a positive value. So C is correct. So we're given a complex number, and we are trying to find that one that is equivalent. So, like always with complex numbers, we multiply by the conjugate of the denominator. So 3 minus 5i over 8 plus 2i. So the conjugate of the denominator is 8 minus 2i. So we multiply by 8 minus 2i over 8 minus 2i. If we distribute here, that equals 24 minus I minus 40i plus negative 5i times negative 2i. But since we have I squared here, that equals negative 1. We'll worry about that later. And in the denominator, we have a difference of squares. So 8 squared minus quantity negative 2i squared. Simplifying this even more, we have 24 minus 6i minus 40i plus 10, or excuse me, minus 10, because I squared is negative 1, over 8 squared is 64, and because 2i squared, we have plus 4. So this simplifies to 14 minus 46i over 68. So immediately we can see that this would simplify to 7 over 34. So we can cross out choices A and B. And there's a negative here, so choice C is our correct answer. So we are given a formula R in terms of F, N, and again, F, and we're trying to express the number of favorable reviews, F, in terms of the other variables. So we're trying to solve for F in this expression. So if we multiply each side by N plus F, we have that F equals R times N plus F. We can also expand here, rewrite this as Rn plus Rf equals F. If we subtract Rf from each side, Rf, Rf, we get that Rn equals F minus Rf. We can factor this, so we have that Rn equals F times quantity 1 minus R. And then finally, we can divide each side by 1 minus R because we're trying to isolate F. Divide by 1 minus R, divide by 1 minus R, F equals Rn n over 1 minus r. And looking through our answer choices, that is answer choice B. So the sum of all values of m that satisfy this equation. So immediately you should notice that it's not factorable, and we should jump straight into the quadratic equation. So we can divide each side by 2. Let's write this here. 2m squared minus 16m plus 8 equals 0. Factoring out a 2, we have that 2 times quantity m squared minus 8m plus 4 equals 0. We can apply the quadratic equation on this. So we have that m equals 8 plus or minus b squared minus 4ac, or negative 8 squared minus 4 times 1 times 4 all over 2a. And in this case, a is 1 because we factored out the 2, so 2. This simplifies 2. We can cancel the 8 and the 2. So 4 plus or minus 2 root 3. So our solutions are 4 plus 2 root 3 and 4 minus 2 root 3. So we kind of have to be smart about it here. We know that 3, the square root of 3 is in between 1 and 2. So we can say, let's say 1.5. So 4 plus 2 times 1.5, that's 7. And 4 minus 2 times 1.5, so that is 4 minus 3 equals 1. Our sum is 7 plus 1 is 8. Answer choice D. So the radioactive substance decays at an annual rate of 13%. We have an initial value. So the amount of radioactive substance is reduced by 13% each year, right? So that means each year, 87%, 100 minus 13%, 87% of the previous year's substance remains. So the initial amount is 325 grams. So after 1 year, we have, so 87% of it, 0.87, remains. After 2 years, that would be 300. So after 1 year, 325 times 0.87 times 0.87, we can see our pattern here. So we can cross these two out immediately, and this can simplify to 325 times 0.87 squared. Option A fits our answer. Okay, so the expression 5x minus 2 over x plus 3, we are trying to find an expression that is equivalent. So 5x minus 2 over x plus 3. This can be rewritten as 5x plus 15 minus 15 minus 2. As long as it's equivalent, we can add or subtract any number we need over x plus 3. This already eliminates our first two choices. So if we simplify this, we have 5 times quantity x plus 3, because we have that in the denominator, it's always good to cancel, minus 17, minus 15 minus 2 is minus 17, over x plus 3. So because this is split into two parts, we want to do the same with r's. So 5 times x plus 3 over x plus 3 minus 17 over x plus 3. We see here that the x plus 3 is cancelled, so we're left with 5 minus 17 over x plus 3. D is our solution. Okay, so we can call x the number of $250 bonuses awarded, and y the number of $750 bonuses awarded. And we have a total of $3,000 in bonuses, where it includes at least one $250 bonus and at least $750 bonus. So we can write that 250x plus 750y equals 3,000. We can easily factor out 250 here. So we have that x plus 750 divided by 250 is 3. X plus 3y is equal to 3,000 divided by 250 is 12. So we have that x plus 3y equals 12. So immediately pops out to me here that we're going to have a factor of 3. And we can choose pretty much any one that fits this equation. So I'm going to choose 3. Number 17, let's see. We are given an equation, and we are asked for the value of b, the coefficient of the middle x term in this equation. So we can expand this to make it easier. So 2x times 3x plus 5 plus 3 times 3x plus 5. This can be expanded to 6x squared plus 10x plus 9x plus 15. Combining like terms, we have that 6x squared plus 19x plus 15 equals ax squared plus bx plus c. We have constants here. We have our x squared term. That means 19 is our b value. Number 18, we have two triangles, let's see, and they intersect at point B. Okay, so immediately it pops out to me that these are similar. So we have 10 here, 5 here. At least, so I would notice that CB would have to be 4 then, by the same equality. So the length of CE, this entire thing, is length of CB plus the length of BE, and that is 4 plus 8 equals 12. Number 19, let's see. So O is the center of the circle, and the measure of angle AOB, that's this angle, is pi over A radians, and we are trying to solve for A. Okay, to do so, we would need to find the length of our radius OA, and that can be given by the distance formula. So we have that, root 3 squared plus 1 squared. Note, this is the same as the Pythagorean theorem, and that equals root 3 squared is just 3, and 1 squared is just 1. So we have the square root of 3 plus 1, which is 4, and the square root of 4 is 2. Thus, we know that the sine of angle AOB is 1/2, right? We have trig rules. 1/2, okay. Therefore, the measure of AOB, not the sine of it, the measure of AOB is 30 degrees. However, we want to convert to radians, so we can take our degrees times pi over 180. That's how you convert from degrees to radians. We get 30 pi over 180, which simplifies to pi over 6. We're looking for the form pi over A. A is 6. Final question. We are given a system of equations where A and B are constants and not known. And we know that the system has infinitely many solutions, so we want to find the value of A over B. Okay, so obviously, if it has infinitely many solutions, the two lines never touch. That means they must be equivalent to each other. So AX plus BY equals 12 must equal 2x plus 8y equals 60. So we don't really know the coefficients of the x and y term in the first equation, but we do see a relationship between the y-intercepts here. And 60 divided by 12 is 5, so we can rewrite this as 5ax plus 5by equals 60. And that still equals 2x plus 8y equals 60. And we can, by equating them, we can solve. So we have here that 5a equals 2 and 5b equals 8. solving for A equals 2 over 5, and B equals 8 over 5. However, we want the value of A divided by B. So A is 2/5 divided by 8/5, which is our B value. This is the same as multiplying by the reciprocal, right? So this can be written as 2/5 times 5 over 8. Multiplying this out, we have 10 over 8 times 5 is 40. So A over B is 1/4. Thank you for watching.